Hey, thank you so much. And I must say, as often as always it happens, especially at Flutter and Friends, it's so cool to see so many friendly faces and people that I happen to see on many conferences in a row. And we even have people here back from Flutter Europe, which is also amazing. Anyway, I hope you will enjoy today's talk. And also, I think we are live on YouTube, so for anybody watching us, hi. And yes, please follow along. And if you have any questions, I'll be super happy to answer them later. I'm Dominik. I'm a Flutter GDE. Currently, I'm working at a startup called Visible, where we are trying to do an app that you could call a Fitbit for illness, for ill people. I will talk about this a little bit more, but that's been one of the greatest journeys for me ever, actually. So before we start, I would like to make a little bit of agreement between you and me that anytime you see a QR code, as a proper mobile developer, I will ask you to just scan it. Like, trust me, just scan every QR code that you will see. um, uh, so this one is obviously just a Twitter handle, but first of all, I will have a question to you because it always amazes me what kind of apps people build with Flutter, and I think it can be also enlightening to you. So you may come from different backgrounds, like agencies, startups, indie dev, things like that. But I think it's very cool to see other types of apps. So let's switch to the Slido that we have here. I'm gonna keep the. I'm gonna put this on the screen. Not sure if, yeah, it will come up down there. Right, so we can see what kind of apps people build with Flutter. So audio recording, computer graphics, super yacht management, healthcare, enterprise, DAW. I don't know what is DAW. What is DAW? Oh, perfect, yeah. Fintech, medical, nice. Medical and fintech somehow is the most popular. Fintech, yeah. This is where the money is, right? Uh, and I'm making this exercise here. I'm doing this exercise here mostly just to gauge what kind of topics are you covering. What else do we have here? There's some sleep tracking, educational support, podcast, e-commerce, nice. Really good topics. So I will post it later on like social media and things. Give me a second, yeah. Cool, now you can see that. So I hope that by this exercise, like we all kind of see now the high spectrum of things that you need to do, like you can do with Flutter, and in turn, or like hence, as a mobile developer, especially when you build for both iOS and Android, and maybe sometimes also for web, you often have to deal with a variety of different topics, like UI, UX, animations, state management, the holy grail, offline support, which is like my little thing and hobby, CI/CD, force upgrading, and also some native, I would say, parts like permissions, different dependencies for native. And one thing that I think is often forgotten or like left for later, and which we're going to talk about today, is just background processing. And we saw a couple of apps that like podcast player or maybe a fintech that they oftentimes just need some kind of background processing. And as much as I enjoy the fact that with Flutter, I don't really have to worry about native code. I don't really have to worry about things like CocoaPods too much, or I can write my logic both for Android and iOS in Flutter. I think there is a huge value in understanding how it works underneath. And I used to work as a backend developer in my first job. And back then, background processing was de facto like a day-to-day job. So most of the things would have been done as a background processes. And when I moved to Xamarin and some other cross-platform frameworks, one thing that back then I didn't realize that, but now I realize it, is that these kind of apps were built quite naively, like they didn't have any kind of component of working outside of its life cycle. So oftentimes you when you build a feature, it only runs when the app is shown on the screen. Only when you actually need it, you may find a way to run something in the background when the user is not looking at your app. Maybe you will even offload this to the backend instead of running this locally on the device. And only after, like, I moved to Flutter, and 2 years ago I joined Visible, I had to actually face a challenge of doing a bunch of different things in the background, especially after, so last year, I did a talk about migrating from online first to offline first for our app, and this led to actually having to write a lot of the background processing code. And we have an app, so Visible is a health tracker. We have an armband that you wear, and it tracks your heart rate. And we don't really expect our users to open the app all the time. So for instance, we need to do background synchronization with the BLE accessory. We don't even, like, people may not even open the app for a couple of days, but we still need to sync their data to the cloud for some additional processing. So it was very crucial for us, having a Flutter app, to be able to do some background processing. And like, I think working with BLE in Flutter is a little bit of a challenge of itself. And then on top of that, you also have to solve a couple of different hiccups and tricks that are related to background processing on native platforms. So today I would like to kind of give you a little bit of a 101 to background processing in Flutter and show what are the ways to achieve that. So first of all, knowing a couple of types of apps that we've seen before, we're going to go through different use cases for background processing. Then obviously, I think that's the crucial part of the talk. We'll see what are some ways to achieve that with Flutter. And at the end, we're just going to ask a question. Not sure if we're going to answer that, whether like you should always use Dart or maybe something else for that. Some use cases. So our app, Visible, needs to synchronize out of lifecycle. When the user closes the app, we want to synchronize the data back and forth overnight. So for instance, when they connect their phone to the charger, a couple minutes later, we want to run some synchronization logic that will send their actions and data to the cloud, fetch them, and so on and so forth. And like, if you have this kind of architecture that allows you to queue your actions for later, it's quite straightforward. But then, of course, there's a question how to achieve it, like how to run this in the background. So in our app, we actually have a special debug mode where we can see different background tasks running as a notification. So for instance, in our test flavor of the app, you can see that this is a task that just started, and I can just easily kill my activity, and then the task is still going to be carried out. And it will take about 20 seconds to finish. And despite user actually closing the app, I don't know how about you. I did a poll a couple months ago, but I found that like over half of people actually always kills the app when they leave. Like that was striking to me because I never kill any app unless it fails to work. But it seems that most of the people actually, when they leave the app, they just swipe it away. And on Android, it's not that big of a deal. But on iOS, if you have any kind of background processing requests, they will not be carried out because the iOS will just prevent any background work, aside from push notifications maybe, to run, which is obviously a problem if you want to do any kind of thing in the background. The other case that I think, again, is often forgotten in like Flutter ecosystem, which I think is still pretty young, is that anytime you upload something or download anything bigger, you want to do it using some native APIs that your system exposes for files uploading and downloading. So obviously, if you go to any tutorial online and you try to look for how to download image in Flutter, you will find something that uses HTTP or DO or anything like that to fetch it in Flutter. And that's perfectly right. But again, if the user leaves the app and maybe they go to Facebook or Instagram, the memory pressure is going to be such that it will just suspend your app. So most of the apps, and you will find it everywhere, Instagram, YouTube, OneDrive, Dropbox, Google Photos, especially on Android, they will offload these kind of synchronization tasks to dedicated services or dedicated foreground services to carry out the work. So for instance, here you can see a OneDrive that synchronizes the pictures. Again, Android is kind of easy here. In case of iOS, it's a little bit more tricky, but still there are some APIs on the in the system that allow you to do it. And I'd argue that anytime it's just easier mental model to think about. Anytime you have to upload something to the cloud, it's just easier to detach it from some process that you do and think about it as something that happens outside of your app lifecycle. And the third use case that we also have at Visible is using the BLE accessory. So in a certain way, connecting to a BLE accessory is a background processing task. And in our case, it's especially important for waking up the app when the BLE armband is in the range of the phone. So when the user turns on the armband or when they approach the phone, we want to wake up the app, synchronize the data, because maybe the next time they will be in the vicinity is going to be in a couple of hours. And the same happens, for instance, when you have a app as a key to your car, or maybe you have a smart lock, and the smart lock unlocks automatically when you approach. So they may use BLE beacons that wake up your app, even if it's suspended. And so these use cases are kind of common. If you have a podcast app, maybe you would like to maybe fetch the data overnight as well, things like that. And having all of these in mind, you make, let's say your client comes to you and they ask you to implement this. You type into Google Flutter background processing or background download, and the first couple of answers, unfortunately or fortunately, I don't know, they are saying in Flutter you can just use isolates to do any kind of background work, which in a certain way is true. Like you can do a lot of the background work in isolates, but I think it's not a complete answer. So let's see what we can actually do, and also we will use isolates to do background work with Flutter. So a couple of ways to achieve that. So for isolates to work, they require Flutter engine to run or Dart VM to run. Your main app runs in an isolate, and you can spin up your own isolate as well. They can be invoked from your main engine that you have in your app. So let's say, I'm going to show you in a second, if you want to do some computation, you can just start a new isolate with a compute function and just create a new isolate. But what is super cool about it, you can just spin up entire new Flutter engine somewhere, and this Flutter engine can have an isolate, and they can communicate back and forth, which is, I think, really cool thing, especially if you consider things like foreground services, adding Flutter to an existing app, maybe handling different interactions like handling intents from home screen widgets. So there might be several of them running at the same time, communicating to each other in some way. So yeah, this is, for instance, an example that we have. So I'm looking forward to some optimizations to the JSON decode. So if you were to the talk in the morning by Slava, he was talking about optimizing JSON decode. But for instance, one way to kind of work around some of the limitations of JSON decode is just to wrap it with a compute function so that the serialization happens on a separate isolate, which works for us. And when we have huge GraphQL responses, we avoid junk this way. Yeah, so the most interesting part for me actually is just being able to invoke the isolate, invoke the Flutter engine from the native platform. And this happens when you get a push notification and you want to run something. So when you set up Firebase messaging, you will see in the docs that you have to have like this top level function that will be called when a new push notification arrives and the app is not running. At first, it's kind of unclear. Why is that? Like, why do I need to have this function? Why can I just like inline what I want to do when the notification comes? And you will see this in a second. In case of Visible, our app and many other apps, so when we have a foreground service and we have some Dart code that we want to run outside of the app, we also want to spin up a new isolate. Or, for instance, as I mentioned, when you have home screen widgets, maybe you have a notification with a button, an action that needs to do some work. and you have this written in Flutter or in Dart, it may be useful to do it. So let's have a look at a very opinionated example, how you can actually invoke the isolate from the native platform. This example is like a mixture of my work and some work from Martin Hude from Lean Code from a couple years ago. But I think it's going to show you how you can easily, using a little bit low-level components, but at the same time, if you look at any library that does this, they are doing exactly the same thing, just with a different API, different interface for invoking the background work. So we'll go into the code. Let me know if you can clearly see what is shown on the screens. I know that in the back it may be a little bit too small. Sorry about that. So we are having a simple Flutter app here and a main function. So I'm trying to implement this in a way that's easy to explain during a live coding. In real life, you would definitely do it differently. But here, I'm just creating a method channel that I'm going to use to communicate with my native platform. So in Flutter, you create method channels to send some messages to a plugin or your native part of your app. So here, I just created two functions, start and stop. And these functions will just start some foreground service on Android and stop it when I want it. So there's nothing spectacular about it. And of course, you can use Pigeon, you can use Dart FFI, things like that. So we will have two buttons, start and stop. Then on the native side, we will just handle this method channel call. For simplicity, I'm just using the main activity. Again, for production, you would probably have your own plugin. And here I just have a handler for start and stop. I would do the same in my Swift code. So I'm going to call start service when the button start is pressed and so on and so forth. Then, obviously, in the start service function, what I'm going to do on Android, if you want to start a foreground service, you create something called an intent. And then this intent, depending on the Android version, is going to either run a foreground service or is going to run just an Android service. We create the connection with this service, and we obviously have a method already written down for stopping the service. Then, in another class, which we call here computational foreground service, and this is the part that I took from Martin Hude blog post, which I highly recommend. There's going to be a link for that. And here, when the service starts, what we're going to do is that we're just going to show a notification, and we will be able later to modify this notification from a different Flutter engine. So here is the function start Dart service that will actually start my Flutter engine. And the Flutter engine has been, so the Dart service. So we take the Flutter engine from our utils class. That's a perfect name, obviously, for helper that will give us a Flutter engine. And we will create another method channel again. This is for simplicity. I'm using the method channel, but this method channel will receive calls from this engine when I want to update the message in my notification. This is the Flutter utils taken from this example, and we will have, it's a lookup table or lookup map of Flutter engines. So here in the create engine, we will just use vanilla Flutter APIs to create a new Flutter engine. We'll take it from the cache, and once we create it, we will just put it into the cache again. We define the entry point, which in our case is the main.dart file, and we also define the name of the top-level function. So this is the part where you need to understand that when you want to invoke the Dart VM, it needs to know what kind of function, what is the main function that you will run. So you can define your custom function. It doesn't need to be main. It can be anything, and you also need to define the file. And of course, at the end, we need to make sure to destroy the engine. Frankly speaking, like this part of the exercise for me is the most exciting because it kind of shows how Flutter engine can be spun up like on demand. Like this is what happens when you have a add to app with Flutter, so existing app, and you want to add a Flutter screen. Or this happens when you, for instance, use any of the plugins for background processing. And we are back on the Dart side. On the Dart side, we make sure to implement this top-level function. We annotate it with the pragma that this is the entry point to the program. And here, there's a super simple logic that on timer, every second, we will just update the notification. But obviously, what you could do here is you could try to upload something to the cloud. You could maybe do a database cleanup. You could try to send analytics events, things like that. So essentially, you're having a separate Flutter app, and it's up to you to define how it works. In our case, we are just going to call the update method through the method channel to update the notification. And here's the app running live. I'm starting the service on Android. On iOS, it's going to be a little bit different, but because iOS doesn't really have a concept of background work, as Android has. But here, I'm killing the app, swiping it away. The main activity stops running, but I'm still seeing the debug log showing me that the counter updates. And then I come back to the app reconnects with the service, and I can stop the service right now. So I can see the progress, and I can stop the service right now. So again, this is a naive example, obviously, but at the same time, for me, it was a little bit enlightening to see how this works in practice, that there's no magic. It's just a couple of calls, first to the native, and then back from the native to Flutter. And if you want to understand this a little bit more, I highly recommend two resources. First of all, a couple years ago, Razvan Lung had a really good presentation at DroidCon about how isolates communicate between each other. Since then, we had a lot of improvements in isolates, like isolate groups and things like that. And then the other one is the example of adding Flutter to the existing app, where they have to create several Flutter engines, not a single one, but a couple of them, and maintain connectivity between them and communication, which is super cool. And obviously, you will find a plethora of different plugins that allow you to do the background work. I think the most popular ones are Flutter Background Fetch and Work Manager, but there's many more opinionated approaches to do it, how to do it. There are some specific ones, like if you want just to download the file, there's Downloader. If you want to upload, there's Uploader. So it's like a pad left or something. Yeah, highly recommend. So in my case, in my example, I have written down this example in Dart. And for instance, at Visible, we also use a lot of Dart code to run in the background, because we already have our models, our HTTP client, our GraphQL client, connection to the SQLite database, all of the things that we have developed, we have access to from Dart. So it doesn't make sense to rewrite this in any other language. So a couple of background tasks are being run in this Flutter engine that is separated. Tricky part, for instance, sometimes is you have to make sure that if you are accessing or modifying some data, it's not being accessed from your main Flutter app. So there's a couple of checks, and there's no real mechanism for locking. So or semaphores. So you have to do this with some, I would say, trivial checks. But it can be done. So most of that. But my hot take for today is that maybe if you have something very specific, it doesn't really make sense to write it in Dart. Maybe it's actually much easier to write it natively directly. So in the example that I've shown a couple minutes ago, I think the main challenge in understanding that is that you're just jumping between the different environments just to communicate between each other. And of course, you can build a nice, clean API to do it. But at the same time, there's always this cognitive load linked to just switching the context between Android Studio and VS Code, and etc. So at Visible, we just, in many cases, realized that it doesn't really make sense to spin up Flutter engine, which has some cost to it will have some battery impact, and many times it's just easier to write the same code in Swift and Kotlin than to try to make up some abstract interface to make it work. So for instance, even notifications or lack of thereof, on Android, the notification system is so much more advanced than on iOS, so it just doesn't make sense to build a unified API for that. There are several ways to do it. I would say the most common one is the foreground service that we are using. But recently, Android team has been recommending to use more dedicated, specialized ways to do background processing. They pose some limitations to foreground services nowadays with Android 14 and 15. So they recommend to use short-running background tasks with Work Manager, or, for instance, recently they have added something called user-initiated data transfers. So this is, for instance, when you want to, let's say, upload a picture to the cloud. That's a valid use case for that. On iOS, I would like to have a cricket sound here, because obviously it's, as often, very different to Android and very limited. So there's like this story that they didn't even have in mind having any kind of background processing in iOS, like back, I don't know, 10 or 15 years ago, when the first version of iOS, the one without App Store, where you would just download the app from the web, like they didn't have a concept of processes having some background work. Everything would happen just in the context of the app. And if you write any SwiftUI or just foundation iOS apps, you will notice this immediately, that the background work framework, let's say, has been built kind of from different, sometimes conflicting ideas. But anyway, obviously they need to have something like that. And the main API that you have on iOS is called BG Task Scheduler. And they have a distinction for short tasks and long tasks. Short task would be just doing like a health check, maybe sending some short burst of data to the server. Long task would be actually, for instance, uploading some pictures. However, these often have some limitations. So what they say, for instance, is there is some machine learning algorithm that will try to learn from your usage patterns, whether they can invoke some background process or not. So if your user doesn't even open the app for a couple of days, it may not let you do, like, invoke these kind of small tasks. So what happens then often, and this is like a real case from production apps, you may send a push notification with a high priority, for instance, that will definitely invoke some code. And in turn, there might be some limitations. Like, for instance, you may not do many network requests, but there are some ways around it. And in our case, what we had to implement was something called state restoration. And this is an API that's, I would say, it was very difficult for us to understand at first. But right now, we are super happy that this exists and allows us to keep the app running whenever the Bluetooth armband is in range of the device. Just to give you an example of, I would say, the patterns that you have to follow when working with background work on iOS. So for instance, here, we just have a, so this is the app delegate, which is the main entry point to iOS app. And when you want to define some background task, you have to do it at build time. So you cannot dynamically create background tasks. You have to tell App Store, essentially, what kind of background tasks the app is going to do, to perform. And you have to create some IDs for that. So for instance, if you have some database cleaning task, you define it as a handler like that. And the handle database cleaning is typically, if it's a short running task, you have 20 to 30 seconds to finish it up. And you can do all the things you need. And then this is how you schedule the task. So let's say you leave the app, your user leaves the app, and this is the moment for you, a couple seconds, where you can schedule the task. Hey, run it. And in this case, run it when the phone connects to the charger. We don't really need to have network connectivity for that, but we would like to run it when the user connects the phone to the charger, and you can test it in real life if it works. The challenge here is that on iOS, when any kind of background process is invoked by the system, it wakes up your entire app. So the difference here is that it will launch the app with the did finish launching with options, right? So you will have some options in your callback at the start of your app telling, okay, at this time, I launched your app in this mode where you can run your background task. But it's not like there's a separate service or separate process running that. It's the same process as your main app. And for us, it was quite difficult because we have, back then, still in the online first times, we had a lot of WebSocket connections. So if the app was still running, all of these WebSocket connections would be connected to our database. So not only we had some costs related to that on the backend, but also the battery usage was quite high. Like all the logging, or we had some periodic tasks that are run when the app is in the foreground. They would still run when the app was not visible to the user, because it was essentially entire app running. So we had to put some checks in place for that. So the trick that we used is called, if you want to look it up, state preservation and restoration. And the specific thing that we have is the Bluetooth state restoration app relaunch. And what it means is that when you are approaching your phone with your BLE accessory, it will wake up the app with a special flag, and you will have some time to assess if it's your device, if it's a device with appropriate characteristics. So for us, it's a heart rate service that we have subscribed to. And we then start the process of monitoring the heart rate. You could easily just stop the processing immediately, like for instance, if you would have a smart lock. But for us, it's important to maintain this connection. And until recently, there wasn't like a really good way to achieve similar experience on Android, aside from constantly scanning for the BLE. But a couple of years ago, they added a similar API on Android that's called companion device pairing. And this is more or less one-to-one of between state restoration on iOS and companion device pairing, essentially meaning you don't really have to, for instance, what we had before was a foreground service that would be periodically scanning for the BLE accessory, and it would just drive the battery, like use the battery very much. And if the device is in the range, we would reconnect and continue monitoring. But with the companion device pairing, it's the other way around. The app gets notified that this accessory is in the range, and you can wake it up. So we have migrated to that a couple of weeks, maybe months ago, and it's been actually having some effect. As often happens, there are some bugs and issues on different manufacturers, especially like Huawei or Oppo or Motorola. They may have some different handling of that, but in general, this is quite solid. And like if you look at the battery usage charts, like they are definitely much better. We don't get these kind of notifications that this app is using a lot of battery anymore that often. But before that, when we would do a lot of BLE scanning, we would get them all the time. Just to maybe recap this a little bit, I think, and I would argue that this is actually a good thing with Flutter, that when you build something and when you actually get to the point where you have to build something more complicated, you just have to understand some underlying platforms. We can coast easily for months, if not years, without even touching the Kotlin or Swift files, not even to mention Objective-C or Java. But like at some point, if you're doing anything more complex, and I would say podcast app is sufficiently complex project to actually have to deal with that, where you just have to face it and understand. In the stock, I just scratched the surface, but in reality, you will have to just spend a couple of hours, if not days, to understand how different systems have the background work exposed to you. And it changes with time. So it's not only between iOS and Android, but between Android 12 and Android 15. Yeah, as I mentioned, there will be challenges that you will have to face. For instance, I mentioned that many people just swipe away the app. On Android, it wasn't a problem until Android 15, which is going to premiere soon, where on Android 15, when the user swipes away the app, you will have very similar experience as on iOS. So many background processes will be suspended or prevented, with some exceptions, obviously. But for majority of the apps, it will mean that they will have to kind of deal with the fact that the app will not be able to run, for instance, nightly. for me, I think the crucial part here was that I just tried to understand how the Flutter engine kind of spinning up works. And after doing that, it was kind of no-brainer just to try it out in our app. And you don't really have to have this abstract APIs like plugins or Firebase messaging. You can, obviously, for ease. But at the same time, it's super easy to get inside of that and understand what is going on underneath, actually. That's going to be all for now. If you want to learn more and kind of get some resources at the website, there's going to be a short poll for you. Yeah, I like that. I like all the phones up scanning for the QR code. You remember our agreement. So I will ask you for a quick survey. If you could share your thoughts with me, and you will also get navigated to the companion page where you will find some links and resources for that. Thank you so much. That's going to be all for today. I think we have 2 or 3 minutes for questions, so I'm super happy to answer them if you have any.
You mentioned using Firebase Cloud Messaging to wake up your background service. On iOS, doesn't that require user interaction?
Yes, so I wouldn't say that you can wake up the background service from the push notification, but you can perform some work that can happen within this bound. So let's say if you need your app to send something over the network, I suspect it will be possible. But not necessarily you would be able to spin up a foreground service. So the foreground service, they now require user to actually kind of have the app open and interacting with that to start up a foreground service.
When you say they, do you mean Android now?
Yeah.
All right, and that's with 15?
So there's a couple of exceptions. So for instance, when you have a medical app that needs to run, you can ask for the permission to do it. But I think for the majority of use cases where you don't specify, you now have to specify the type of the foreground service, whether it's like a music player or accessory or anything else.
Right.
But for a majority of them, I don't remember the exact types, but you will have to have the app running at least in the foreground to spin up the foreground service. You will not be able to invoke the foreground service from the background.
Right. Thank you.
Anyone else? No.
Thank you so much.
Yes. Thank you, Dominik.